Hello everyone, and welcome back now to session 7 of low pressure boiler operation training. Wow, if you've stuck with this here whole regimen of training up to session 7, I gotta compliment you. Don't give up on it. Make sure that you follow this through to the end so that when you're all done with the training, you fully understand boilers and how they operate and how they tick. Well, today's session has to do with the feed water system, and more specifically about the treatment of boiler water. Now, you remember last session we talked about the draft system. And there's basically 4 big systems that have to do with, that are tied together with boilers. You got the draft system, you got the feed water system or water supply system, you have the fuel system, and then you have the steam or hot water distribution systems. So today we're concentrating on actually the feed water system and the boiler water system and the treatment of that water. Now, just like almost every session that I've started out, people can happen by chance in on this training. And if you have happened in on this session 7 and you haven't went through the course and you're serious about learning how to operate boiler systems, I would recommend right off the start that you hit or tap on the subscribe button on your screen. And by doing that, it will bring up all the various sessions, and then you can go back and go to the introduction and then session 1, 2, 3, 4, 5 and follow them methodically right on through. Each session I recommend that you purchase boiler books. And if you have somebody that has a set of these, wow, if you could talk them into borrowing them at least, that would be great. But having your own boiler books gives you the advantage of going back and reviewing and referring to these books as you operate your boilers. In the future, you may want to step up your training and perhaps step up your licensing. And there's no better way to do that than to go back and read through your boiler books. The first boiler book that I'd like to talk about is a textbook, and it's made and supplied by the American Technical Publishers. This here is the 4th edition book. It's called Low Pressure Boilers. And it's made by and published by the American Technical Publishers, written by Howard Steingris. This is a standard in the industry for anybody that wants to learn about low pressure boilers and the operation of them. So go get the book. You just can't beat it. And just by listening to my video series is really not enough, because there's so much more in the boiler book, and I take you through it chapter by chapter by chapter. You can spread this out over a period of weeks or even a couple of months or better and absorb it slowly and understand it thoroughly. Now, to complement the textbook is this book here that American Technical Publishers put out. It's called Low Pressure Boilers Study Guide. It has just all kinds of information that goes chapter by chapter, and it will enhance your learning abilities as you go through these courses. So the number one thing I'd recommend is order these boiler books. Go to American Technical Publishers online and you can order them from those people. Right now, we currently have, or they currently publish, the latest version, which is the 5th edition of low pressure boilers. So this particular edition pretty much follows the other older versions of the book, with the exception that they don't include information on coal and the burning of coal, which is a rarity today with low pressure boilers. Also included is an enhanced chapter on hot water boilers. So there's more and more boilers being converted over in the heating industry on small, medium, and fairly large facilities. They are gravitating away from steam, and they are going toward hot water boilers. In the last 20 years, the hot water boilers have also gravitated toward high efficiency boilers, or what they call condensing boilers. So get those books. Now, if you are from Minnesota and you want to get a beginner's license in Minnesota, the beginner license allows you to operate up to 50 boiler horsepower for high boilers, high pressure boilers, or low pressure boilers under the direct supervision of a qualified boiler operator. And this is the book I'd recommend that you get. It touches on high pressure a little bit and a lot on low pressure. Safe Boiler Operation Fundamentals, Special Engineer's Guide for the State of Minnesota, published by the American Technical Publishers. So follow along in this book as I go through the various sessions. Try to match the sessions up with the various chapters in the book. It'll greatly enhance your ability to understand how to safely operate boilers. For those of you that don't know, my name is Ben Weekly, and I herald from the northern part of Minnesota. And for the past 30 years, I have operated low pressure boilers, and for about 25 years have conducted boiler training for men and women who was doing the same type of work that I do. And I have enjoyed that. A few years back, I retired from active work, but I have still kept up the boiler training, and it gets me into a classroom setting, gets me into various boiler rooms, and I can rub elbows with the guys and women that did the same type of work I've done for many years. It's a pleasure to do that, and I don't consider myself some kind of professional trainer. I just want to explain things slowly to you so that you can grasp how to safely operate boilers. So sit back and take your time, take some notes as you go through these courses. I want to tell you a little bit of story, a little story about a fellow that I had in boiler classes quite a few years ago. He was testing up, so he wanted to get a better understanding of boilers so that he could pass his next highest exam and get a higher classification of license. Well, he was in my boiler class, and sometime period of time later, it may have been a year or two, maybe even more, I seen an article in one of the newspapers, and the article said that where this man had been working, they had to retube their boilers. And so I thought, wow, this guy is going to get himself almost new boilers to operate. So they spent tens of thousands of dollars. Did you hear that? Tens of thousands of dollars to retube these boilers because they were leaking. Well, it was roughly 2 years later that I got a call from this man. And in my boiler classes, I would often tell of people that I was teaching that if they had questions or concerns about their boiler operation, feel free to contact me, call me or whatever, email me. Well, anyway, I got a call from this man, and he said, Ben, this is so-and-so, and he said, I got a problem with my boilers. Oh, really? It's like what kind of problem do you have? And he said, well, my boiler tubes are leaking bad. I said, what do you mean your boiler tubes are leaking bad? Didn't you just have them retubed a couple years ago? Well, yeah, we did, he said. I said, well, how could they be leaking bad if you just had brand new tubes, everything done all new? I said, you're testing the boiler water, aren't you? And he says, after a long pause, well, we don't test it. I said, well, who's testing your water? Well, some chemical guy tests it. I said, how often does he come around? Several times a week? No. Whenever he gets here, might be a month apart, a couple months apart, whatever. I said, seriously? You should be testing that boiler multiple times a week, if not on a daily basis. Well, to make a long story short, they then spent hundreds of thousands of dollars after only being 2 years with new tubes, hundreds of thousands to convert the steam system over to hot water. Your water in your boiler is absolutely critical. The chemical composition of it is absolutely critical. Steam, especially. Steam boiler water has to be babysitted on a daily basis. Sometimes larger boilers, they require constant monitoring of the boiler water. So, water is probably the most universally used product or the most universally used substance on the planet. In northern Minnesota in the wintertime, it freezes thick on the lakes and rivers, and you can walk on it. You could drive on it, create a road out of it. We swim in it. We bathe in it. We wash our clothes in it. We hydrate ourselves to keep ourselves from drying up and dying. Water is critical to our existence. And in boilers, water chemistry is absolutely critical to the efficient use of the boiler and for the long-term durability and survivability of boilers. A boiler that has been, a steam boiler that has been properly cared for, both on the operation end of routine maintenance and on the chemical end of the water, those boilers can last 40, 50, 70, 80, 100 years and still be going. But I'll guarantee you one thing, if you ignore the chemical composition of your water in a steam boiler, you're not going to have it around very long. Hot water boilers, the water is still important. Some people ignore hot water boiler composition and pay a price for it. It doesn't always show up overnight, but you will pay a price for it. So make sure that hot water boilers on a fairly regular basis, it might be twice a year or whatever, but at least on a regular basis, you have some way or someone that tests that boiler water for the pH levels and for corrosion inhibitors in the boiler water. So don't forget about hot water boilers, water chemistry. Some of the different water systems that we have in a boiler, of course, we have the water that's in the boiler, called boiler water, yeah. And then we have feed water that is brought to the boiler. And feed water can be made up of a combination of city or well water coming in and condensate water coming back. Could be put together in a feed water tank, and then as the boiler needs the water, it gets pumped into the boiler. So you have feed water, boiler water, and all of this water has dissolved solids in it. Any water that comes out of a city supply or a well has dissolved solids in it. It may have went through some type of treatment, but it doesn't eliminate all of it. So that has to be monitored and cared for. The treatment of boiler water increases efficiency and prevents damage of the boiler, the internal systems of the boiler. You can have corrosion and pitting and problems and destruction of your boiler going on. You can't see it, you can't smell it, you can't hear it. There's only one way to monitor that, and that's through testing of the water. One thing that is very detrimental to steam boilers especially is scale buildup on tubes. Scale buildup usually comes from the minerals in the water, magnesium especially, and calcium even more probably. So you know, when you were at home and your mother or grandmother had a teapot, my ancestry is English, so there was always a teapot in the kitchen. And the teapot would be used for more than just tea, of course, but as that teapot was used over a period of 6 months or a year, you'd open the lid and look inside the teapot, and it would be scale all around the side of the teapot and all across the bottom. And every once in a while, my mother would have to soak that teapot for maybe a day or two in vinegar water and then scrub it out and get rid of that scale. The same thing is happening with boilers. If boiler water is not properly treated, it can have pitting occurring in it. In other words, the corrosion and pitting of the tubes and boiler surfaces actually eats away at the metal material of the boiler itself. Like I say, it's a silent killer. It's a silent internal killer. Now for pitting, usually pitting is caused by too much oxygen in the water. There's different ways to get rid of that oxygen. One being heating the water up over 160 degrees, 180 up to 195 or 200 degrees or better, as long as it's not boiling. But the water coming into the boiler, if it's preheated like that, it drives off excess air and excess oxygen. So oxygen inside of a boiler is extremely detrimental. It wants to pit and eat away at the surfaces. So what do? We add chemically something called an oxygen scavenger. In other words, you can see the picture. It goes around as a scavenger, and it picks out and clings to and absorbs and eats that oxygen so that it does not create a problem in our boilers. Now the chemical that's most commonly used, and there might be commercial names on the box or on the pail, but the most common chemical used is a product called sodium sulfite. You add sodium sulfite into your boiler water, and it will absorb that oxygen, and the sodium sulfite will turn into sodium sulfate. The sodium sulfite will turn into sodium sulfate, and it becomes heavier than water and has a tendency to settle to the bottom of the boiler. And when it does that, you do what's called bottom blowdown, and you get rid of that oxygen and sodium sulfate in that manner. So you get it out of the boiler. Now, the easy way to remember this is sodium sulfite fights oxygen. Sodium sulfite fights oxygen, and it turns to sodium sulfate after it ate the oxygen. Sodium sulfate ate the oxygen. Hopefully that will help you remember the difference in sodium sulfite and sodium sulfate. Sometimes it's hard to keep that in your mind. The other thing that is detrimental to a boiler is when the pH level gets out of whack. You know, the pH level is 0 to 14. We probably learned that back in junior high school. 0 to 14 is the pH level, and the number 7 is the neutral. It isn't alkalinic and it's not acidic. Anything under 7 becomes acidic and corrosive and can pitch your boiler. Anything above 7 is alkalinic. Too high of alkalinity will cause what's called caustic embrittlement in your boilers, and it will show up in areas where your boilers are jointed together, and wherever there's stress areas inside your boiler, around your fire tubes, and so on and so forth. So being too low on the pH scale can chew away at your boilers, causing pitting. Anything under 7. Anything above 7 is alkalinic. So you say, what's the most ideal pH level then for a boiler? Well, typically the pH level that you want to have in your boiler would vary between maybe 10 and 11.5 or 11.5. So keep that in mind. You want the boiler water to be slightly on the alkalinic side, not above 11.5. So there's different ways to achieve that. Now, in every steam boiler especially, in every steam boiler, there is a couple of issues that can arise because of the water not being treated properly. And one is called priming. Priming is when the boiler is boiling so heavily that it's throwing large pieces of water or slugs of water, and it gets up into your main steam lines. Now, when that happens, you can endure something called water hammer, which is destructive to the steam system. So that's called priming. And then there's also a term called carryover. Carryover is when smaller particles of water gets thrown up into the steam lines. That too, if it's done on a consistent basis, can lead to water hammer in your steam system and cause destruction of your steam system. Can cause destruction of valves in there, cause destruction of your elbow systems, your steam trap systems. So you don't want to have that. And the most common thing that causes priming and carryover is what's called surface tension. Remember, your boiler, your big round boiler on a steam boiler is only filled so high with water above the tubes. And if you get too much tension on that water, the steam has a hard time exiting the water and getting up into the steam chamber. And if it has to push hard against that surface tension, it will throw water up into your steam lines and cause you all kinds of trouble. Surface tension, I think we've all seen surface tension in water. If you take a clean glass and fill it with ordinary tap water, you can actually fill it to the point where it's actually higher than the surrounding edge of the glass. And it can stay that way because of surface tension. Now, the surface tension can also cause what they call foaming inside your boiler. So typically foaming inside the boiler is caused by either too outlandish or out of sync or out of whack boiler chemicals. Too many chemicals in the boiler can cause foaming, or it could be caused by oil getting into the boiler. Probably the most common way for oil to get inside your boiler is if you are preheating the water coming to your boiler with steam. And that steam heater as well can be preheating the oil that's going to your burner. Now, if you develop a hole in that steam coil as it's heating the oil, it can get back into the condensate, backfeed into the condensate and get into your boiler water. So that's one way that oil could potentially get into your boiler. Brand new boilers or boilers that had just recently been worked on, a lot of times will have oil inside them, and there's a process that they go through to boil out all the oil out of the boiler, drain it, get rid of it, and then refill it and start operation. But it's easy. If you want to see what oil and water can do, take a pan and fill it maybe 1/4 full of milk and start boiling. If you do it with water, it'll boil nicely. But if you do it with milk, the oil that's in the milk will foam up and will rise to the top and boil over onto your stove. So that's the same process. If you get oil inside your boilers, you can have that foaming effect. And the foaming will go up into your steam lines and cause you all kinds of issues. So boiler water treatment is critical to the safe operation and efficient operation of a boiler. You just cannot neglect it. Now, one of the other things when it comes to water is called dissolved solids. We've talked about dissolved solids. All of the water that we get either from a well or from the city supply has dissolved solids in it. The only way you could get rid of that would be to buy perhaps distilled water, which would be extremely expensive to do that. So all water has dissolved solids in it. If you have too much dissolved solids, you can create surface tension. And so the dissolved solids can only be measured, usually the most effective way anyway, is through a dissolved solids meter, or sometimes called a conductivity meter. A dissolved solids meter will let you know how much dissolved solids are in your water. Well, what's a dissolved solid? Well, the easiest way to demonstrate that is if you took a glass of water and you put a teaspoon of salt in it, or maybe a teaspoon of sugar in it, and you stir it up. When you first start to stir it, you can see the solids in there. But after it dissolves, you can't see it any longer. You can hold it up to the light and there's nothing in the water. Where did it go? it dissolved chemically into the water. And so if you have dissolved solids, too much dissolved solids in your boiler, you can have all kinds of problems. One thing that I always recommend, for those of you testing your own water, make sure you have a dissolved solids or conductivity meter. If you do not, you are, in my mind, you're kind of flying blind on this. And if you can't determine what your dissolved solids are and monitor that consistently, it can lead to the wrong type of readings on the alkalinity of your water. So if your alkalinity seems like it's getting out of whack, you keep adding chemicals to take care of the alkalinity, where in fact it's the dissolved solids that are causing you problems. When you test your boiler water, make sure you have a daily log. Perhaps you have a log that covers an entire span of a month, and you go through and you test that water and you write that down so you have a history of it. And you write down in your logs how much chemicals that you're adding and so on and so forth, so that you have something to look back on if you do have a problem, and you can see very easily how you remedied that in the past. There's a couple different ways to treat boiler water. One is an external treatment, and the other is internal treatment. What's the best? Well, by far the best is to treat the water before it gets into the boiler. Once untreated water gets into the boiler, now you have problems inside of your boiler. It's much easier to treat the water outside of your boiler. Some larger boiler systems will have preheat tanks. So the water comes in and it gets preheated. It drives off the excess air, it drives off the excess oxygen, and it gets treated chemically so that by the time it gets fed to the boiler, you have really good grade boiler water. So you don't have to worry about it contaminating the inside of your boiler. Then, of course, there is internal treatment, and that's the last thing you want to do. But many times boiler operators will, I would recommend anyway, that you get in touch with a good boiler chemical guy that can come around and reliably test your boilers and give you information on how to test them yourself when he's not there, and how to make adjustments in the feed that goes in, the various chemicals that get fed in. So you are treating water many times from a boiler treatment chemical guy, and he is giving you advice on how to put different chemicals in to help your boiler itself, oxygen scavengers, steam line treatment, and even condensate line treatment. There's many different types of treatments out there, but preheaters will help, because you can treat the water in a preheater system before it gets to the boiler. Now, there are other attachments that come with boilers, fairly large systems, especially steam systems that have intermittent use. And so when there's intermittent use, sometimes you can get excess condensate coming back that the feed water tank cannot handle. So you'll have what's called a surge tank. In other words, that surge of water coming back temporarily because of the intermittent use is captured. And why do we want to keep that water? Well, it's water that's went through the system. It's been treated. Boiler water chemistry treatment is not cheap, but it's far more expensive if you ignore it. Far more expensive. Many boiler operator systems out there have water softeners, and of course there's a number of different types of water softeners, but a lot of that water softening helps get rid of the hardness of the water, gets rid of some of the dissolved solids and some of the suspended solids as well in the water. So most steam boiler operations will have a water softener system, so the water goes through that before you even begin to retreat it in your feed water system. Now, some of the feed water systems that are out there, there's a couple different types. There's the automatic systems. They use little dispensing pumps, or there may be a solenoid valve tied to city water coming into your feed water tank, and it'll turn on each time and it'll dispense a certain amount of oxygen scavenger into the water. And sometimes these systems have a very large tank. You add a recipe that your chemical guy gives you. You put in so much water, you put in so much of the various recommended chemicals, and you create a slurry, and that slurry then each time is on a routine basis, either on a use basis or on a time basis, is fed into your feed water tank so that you can maintain good feed water going to your boiler. So that's the automatic type system. Automatic systems treat the water outside of the boiler before it gets there. Now there's another one which is called a slug feeder or a bypass feeder. So what this system does, many operators have both, and occasionally they will use the slug bypass feeder to add a little bit more of a chemical to help catch up and not having to remix the entire barrel where all of the chemicals are put in based on a recipe, and not have to adjust their the feed pumps from those chemicals. So there's a slug feeder, or commonly called a bypass feeder, and that's external to the boiler, and it can help you catch up. So if your boiler is running very nicely and your chemicals are running very nicely and the testing is going good, but over a period of a couple days or maybe a couple weeks, suddenly your oxygen level starts to drop, you might take and add in a certain amount into a slug feeder, and it pushes that chemical into the boiler and helps you catch up with your boiler water treatment. The other thing that we do for treating water is blowdown. There's several different types of blowdown. One is called surface blowdown, and that helps with surface tension. So surface blowdown, well, the valve for that would be up at the surface level of the water. If you have too high a alkalinity or too much dissolved solids, you would maybe turn on your surface blowdown and help get rid of those heavy concentrations on the surface of the water. There's another system called the bottom blowdown, and when you do bottom blowdown on a boiler, you want to sometimes shut off the boiler, or wait until the boiler is in low fire or perhaps off, and let the sediment that's in the water gradually settle to the bottom. Now, when you open up your bottom blowdown valve, you want to open it up slowly. Some boilers have what's called a slow opening valve. It'll be a valve where you turn at least 5 times before it's completely open. There are other smaller boilers out there that don't have that. They maybe have a ball valve. But in any case, the last thing you want to do is do a bottom blowdown and open up the valve quickly. I relate this back to my childhood. Every Saturday night, I had to take a bath whether I liked it or not. And so Mom would get the bathtub ready and get the water all set, And then I would go in there and jump in, and I would soap up, and I would scrub all of the grass stains off of me and get the grit out of my hair. And then when I was finished, I had to get out and dry off. And then it was my job to drain the water out of the tub and clean the tub. Well, don't you remember when you did it? If you pull the plug out of the tub real fast, you open that tub real fast, the water would start to circulate down into the drain and create like a little tornado effect or hurricane effect. The water would actually start draining from the top down into the drain. And then the last thing that would show up was all of the crud, all of the grass, all that stuff left on the bottom of the tub. Then that would start to slowly go toward the drain, and it would never drain out completely. I'd have to re-rinse the entire tub. So what I found out is if I pull that plug out slowly, it would start that stuff on the bottom flowing toward the drain. And it made it much easier for me to clean the tub. So in a boiler, do your bottom blowdowns in low fire, or perhaps when the boiler itself is shut off. And open it up very slowly and let that material, the sludge and dissolved solids and so forth, gravitate towards your bottom blowdown valve and exit your boiler. Well, how often should you do this? Well, probably on the recommendation of your boiler guy. Bare minimum, at least once a day. Bare minimum, at least once a day. And if you're having chemical issues, perhaps more than that. So that has to do with your bottom blowdown. It has to do with the history of your chemistry based off your boiler logs. This is how long I should blow it down. Do I open it slowly and leave it open for 3 seconds, 5 seconds, 20 seconds? It will depend on your log history and the recommendation from your chemical guy. One thing with bottom blowdown, you want to make sure that you never blow down the water to the point where you expose your tubes. The water level in your gauge glass always has to be there. Don't let it drop out of sight on your gauge glass, even if you have to have somebody else watch it, especially if it's on the opposite side of the boiler. So keep in tune with that one. The other blowdown system is what's called a continuous blowdown, and that's usually about midway in the boiler, and that sometimes is set and is just left, and it just continuously drains, and it helps stabilize the chemical composition in the water. So for those of you out there that are starting to learn about boilers or adding to your boiler knowledge, when it comes to steam, remember they got to be babysitted all the time. Boiler water chemistry is critical to the efficient use and the longevity of the boiler itself. Well, this is session 7. Make sure you read up in your boiler books now. Hopefully you've ordered those. And we'll see you next time on session 8. So thanks for watching. Appreciate it very much. Hit the subscribe button so you can see all the various channels so that you can go methodically through these training programs and methodically through your boiler book to match the sessions. Thank you again.